Hi guys. Today we're going to study the Z transform of trigonometry. In this problem, we're going to solve or find the Z transform of cos, and this is the function. Okay, let's begin. Alright, so to begin, let's summarize the steps that we're going to do. First is we're going to apply the Euler formula. Second is we're going to use substitution. Third is we're going to use Z transform. And number four is algebraic manipulation. This is long, but this is easy. Okay, first off, alright, so let's begin. Okay, so remember that the Euler formula of cosine in this case would be alright, that's the Euler formula that we're going to use. So now our problem would now be, okay, so applying the Euler's formula would now be look like this. So as you can see, I use some of the properties of Z transform. Okay, this is now our formula. Okay, so since 1/2 is constant, so what will happen here is say, okay, so we're going to evaluate or find the Z transform of this one. Okay, so as you can see, one that we're concerned now would be just this one. Okay. So in this case, you could just ignore the use of n, but it's just really a limiter of this function. Okay, so what we're going to do next is we're going to use the number 2, use substitution. Okay, so our substitution here would now be okay, so in my previous video I used this alpha. Okay, so an example would be this one. So I have a video of this one. As you can see, I used this. So just for the sake of the simplicity, I'm also going to use that variable. So E plus or minus J W. Okay, so we're just going to ignore that letter N. Okay, so as you can see, we substitute it because this one is a constant. So it could fill this for the sake of simplicity, and also to easily solve this, we're going to substitute this with alpha. Okay, so as you can see, the same variable that we're going to use in this one and also in this one. Okay, so now our equation would now be okay, so that one. So we're now just going to evaluate this one and also this one. So as you can see, in my previous video, I've worked on this example. So this is a formula, or you could use it on this one and also on this one. Okay, so now the end product of that would be this one. Okay, so we're going to use that. Okay, so we're going to use this one for this one, and also for this one. So now our Z transform. So now we're going to step 3, which is Z transform. Okay, so to do that, the problem would now be, okay, so now that's the Z transform of our problem. Okay, so before we go for the step 4, we're just going to go back with our original function, which now be x of z is equals to okay, so now that's our z transform. Now what we're going to do next is we're going to do some algebraic manipulation so that we could further simplify this. By simplifying this, we're going to revert it back to the cosine form. Since it's in a transform, there is no n. Okay, so what we're going to do here is, okay, so we're going to factor out that 1/2, and then okay, so what we're going to do first is we're going to multiply. So that would be, so 1, and then okay, so and the last one would this one. Okay, so to do that, this would become positive, and then so properties of exponent, and then z -1, and then 2. So that's our denominator. Okay, so now what we're going to do is we're going to deal now with the numerator. So as you can see, that's the denominator, and the numerator would now be 1. Okay, so now we're going to simplify this one. So numerator first. Okay, so to simplify this, it would now be 2, because I add those 1, and then I forgot to add z -1. Okay, and now what we're going to do here is we're going to simplify the denominator. So it would now be 1 z -1. Again, we cannot add this one. Okay, so in this one, this will become number 1, and then the simplified version of that would now be like this. Okay. Okay. I'm sorry for that. Okay, so as you can see, and then after that would now be, okay, so let's factor out the negative of this one, and then this one. So it now would now be 1/2. I distributed this, by the way, and then okay, so to simplify that, the answer would now be, so this one is cancelled, so now it's going to be 1. Just bear with me, because after this stuff, it would now be neater. Okay, so this one is you should have be able to sense this, that this one is um, the Euler's identity. So what we're going to do here, the z raised to negative 1 would be factored out. So now we're just going to substitute those highlighted. So it would now be cosine. Okay, so that would now be result. So after that, we're going to combine the denominator. So it would leave to, this is the satisfying part of um, solving mathematics, because as you progress, it becomes neater and then simpler. Okay, so as you can see, this one, specifically this one, looks like a Euler identity. What we're going to do here is recall. Okay, recall that um, cosine W is equals to 1/2 E. Okay, so as you can see, we're missing those 1/2. So what we're going to do is we're going to manipulate this identity so that we could use it in this case. So, and also just to remind you that we're going to factor out those negative so that this would become addition, so that it could match our criteria here. So we're going to put that now in our equation. So now the answer would now be 1 minus cosine. Okay, so as you can see, this one is our final answer. All right. So that's, as you can see, it much simpler and neater. But before we finish this video, we're going to find the region of convergence. I should have discussed this on the upper part, but it's better than late than never. Okay. So in this one, so as you can see on this one, on my previous video, the region of convergence is this one, so we could just copy paste this one. So I tried to explain this section, so but we're just going to copy paste it here. Okay, so and remember that our alpha in this case is equals to plus or minus E J W, and this is equals to 1. Okay, some of you might asking how it became like this, because remember that the z-plane is in z-plane, or the z transform is in z-plane, and we have to find the region of convergence. And if you find the hypotenuse, okay, so we're going to use MATLAB so that I could explain it briefly. Okay, so example that we have like this. So remember that the W is okay, so example, so the W will be replaced by pi. Okay, Okay, so as you can see, it's negative 1. How about let's change it to 2 pi? Okay, so as you can see, it's positive 1. But how about if we change it by pi over 4? So it's in 45 degrees. Yes, 45 degrees. Okay, so pi over 4 would be, oh, so as you can see, it's not 1, but how will you explain this one? It's because this is the hypotenuse of this one. So let's try to look in this one. Okay, so as you can see, mhm, this is a unit circle. And as you can see, the region of convergence here is 1, negative 1 to be exact. So let's change it to 4 and then evaluate. So as you can see, it's now here, which is this one. So as you can see, this is the hypotenuse, which mean if you try to solve this by using the hypotenuse formula, the b squared plus c squared square root, um, you're going to result into 0.999 or approximately equals to, since the MATLAB does some rounding off. Okay, so that's why it became 1. Okay, so therefore the region of convergence in this case would equal to 1. Say, okay, so that's our final answer. Okay, so as you can see, the only long part or the tricky part that we should be aware of is the algebraic manipulation. Okay, so to summarize the video that we have is we find the z transform of this trigonometry, and we just apply the Euler formula at first, so this is vital. Number 2 is use substitution, and number 3 is z transform, and then the algebraic manipulation. Okay, so thank you for watching, and keep posted. Bye bye.